Hello everybody, and thank you for joining us today. Today we are joined by Richard Conway from Elastacloud and John Garidis here from Byte Software Services, who will be going through our Microsoft Big Data Solutions webinar with Elastacloud. So I'm now going to hand over to John Garidis.
Good morning everyone, and thank you for joining us here today. Microsoft and Bytes have been working together for many years, and recently we've been rewarded the #1 Azure partner in the UK with 30% market share. What we have noticed in the last, certainly over the last 6 months, is that a lot of our customers are focusing on big data and analytics, and we decided that this would be a good start for us to start a webinar about big data to show you how you can unlock value from your data sources. And it doesn't really matter the size of the data, the bigger the better, in fact. You're also going to hear about case studies from customers that have already adopted this technology and are achieving big rewards. You're also going to understand what Microsoft Azure has to offer in the big data space. And also, if you're not thinking about Azure, perhaps you should start thinking about it now. And we are also going to show you how you can put together projects that give insights to your customer data and enable you to do recommendations. And finally, we're going to show you how you can evolve customer lifetime valuations using models and much more. Without any further delay now, I'll pass you to Richard, who is a specialist in this subject. Richard, over to you now.
So thank you very much, John and Sarah, for inviting me to speak today. As John said, I'll be talking about big data and what the Microsoft Cloud, Microsoft Azure that is, can offer in terms of big data scenarios. And I wanted to keep this at a fairly high level, just generally because I thought it was a better idea to present some case studies of some things that we've done and talk around some of the issues that you'll come across and implementation details and how over the last 2 years the Microsoft Cloud has really turned into a fertile ground for big data applications. So to introduce myself, my name is Richard Conway. I'm a director of a company called Elastacloud. I'm an Azure Most Valuable Professional and an insider. I'm on quite a lot of steering committees to direct the Microsoft Cloud, and I work across various lines of business space, so I've got a good understanding of all of the implementation challenges in certain business sectors. Okay, so can we have the next slide, please? So we're an Azure Circle member, and we have been for the last 2 years. We have solely focused on how to use the cloud at scale. It's really important to understand the sorts of things that the cloud is good at out of the box. One of the key areas of focus for us has been that because we have access to all of this computing resource, we want to actually use it. So we start from the premise of this idea of scale out, and we'll look at scale out compared to very different compute models with relational databases which are more to do with scale up. So there's a very natural fit with the cloud and these scale out methodologies, which is really why big data shines. So we've had around about 2.5 years experience of big data technologies on Azure and machine learning more recently, and prior to that we spent 2 years doing HPC, which is high performance computing, which is really pushing the boundaries of parallel workloads and getting them to execute in hours rather than days or weeks. We're currently undergoing several case studies with Microsoft for 3 companies that we've done fairly different projects for that I want to present today and explain to you the solutions. We're frequently called on by different departments in Microsoft to help in aid in big data projects where we've been innovating and really tying a lot of open source frameworks which have a much more natural fit on other clouds like Cloudera and Amazon Web Services, and we've been tying them to Azure by writing open source code that anybody can download and run themselves, to the effect that that a lot of these frameworks become very, very natural to run in Azure. On our community focus, Elastacloud created the Windows Azure user group. This was around about 3 years ago, and now we Okay, so I'm just going to start with a brief statement on data science, because there's a lot of these words that are bandied around, and they're sort of buzzwords that are overinflated by the press, and it's really important to understand what their fit is in what context. So data science is a combination of a lot of things, but in terms of what it means within the cloud, it essentially means, from an enterprise perspective, the marriage of software that can scale and being able to tap into the vast repositories of data that people have been collecting and organizations have been collecting for a number of years. So without the two things, you really, really can't put analytics on top of it. So I think from the cloud perspective, the fact that you can now store terabytes to petabytes of information very, very cheaply and access it on demand in a highly resilient manner is part of this. The other part of it is the ability to have thousands upon thousands of virtual machines literally on demand to be able to drive an analytical process across this data. Next slide, please, Sarah. So just to introduce you to a concept that we talk about all the time, it's this idea of a commoditized query. One of the factors involving the setup of new projects is that procurement of hardware, and it's very time consuming to go through this decision making process. It tends to be fraught with a situation where a certain amount of hardware will be brought in, it will be overused, and then more will be needed to be procured, and you end up with this staggered effect. Now, if you can imagine, this in itself for standard applications is completely exacerbated when you're talking about big data projects, because with big data you end up in a situation where you need a very, very large amount of resources. And generally, in my experience, when we've had these kinds of projects which have been run on premises, you tend to have project teams that that tend to use these clusters of compute, virtual machines, and it gets saturated. So the model that the cloud adopts is this idea of creating everything in a transient manner. So if I have my data stored in the cloud and I want to do some analytics over it, I might only need to process this in batch for 3-4 hours a night. That's all I need the hardware for. So we talk about this idea of a commoditized query, where essentially we provision something, we provision virtual machines in the cloud at a certain time. There's a certain time that it takes to spin up these virtual machines. Then you can execute queries across these data sets and spin them down, and you're effectively paying a least cost for the time that you run this. So it's a very, very different model, having this sort of on-demand, always available model. If we could go to the next slide, please, Sarah. So just to give you an idea of the power of Microsoft's big data framework, which I'll talk about, called HDInsight. In a specific example, we took 500 servers and we ran HDInsight for 20 minutes across 40 billion data points. Now, just to give you the context that this was in, this was searching every single web request from a particular organization since they were formed. So when I refer to this scale-out methodology, you can really begin to understand that because these big data frameworks scale linearly, it means that you can always add more resources to cut the execution time down. So there's no problem that is too difficult in terms of a time challenge that you'll find that you'll have an impediment with in the cloud, because Microsoft in this case will be taking all of the cost of ownership for these, and you'll just be taking them for a certain amount of time. If you want 1,000 servers instead of 500 servers, then more or less you'll have a linear scalability, and that 20 minutes will be cut down by half. Okay, next slide please, Sarah. So one of the things that I'm going to this isn't really an introduction to Azure in the cloud, but what I want to do is I want to highlight a very, very common big data pattern. And I think that as a number of you are on this webinar, it will probably resonate with many of you about the types of things that you would want to do with your data, how you would want to view this, how you would want to build reports against it. So a key workflow with big data is this idea of being able to collect telemetry. It doesn't matter what this telemetry data is. It could be telemetry data coming from web server logs. It could be telemetry data coming from devices like a mobile phone, or even a small device within an Internet of Things type thing. It could be gaming data from an Xbox game. It could be an event that from a sales database or an event store of some kind. And what we'll tend to find is that the applications that receive these we can package up really nicely within Azure websites, where we can roll these out literally within about 5 seconds and scale them out in any direction that we want, and ensure that we've always got enough resources to receive this telemetry data. When the telemetry data is pre-processed using this website's technology, we then effectively issue a service bus message. Now the service bus is the messaging subsystem of Microsoft Azure. It's a very highly resilient, highly performant message bus, which allows you to publish both to inside and outside of Microsoft Azure. So that means that I can even consume service bus messages if I want on a different cloud, like AWS C2, or I can consume these on premises. So it's a really good format for generating events from discrete parts of the system. So this common pattern, which we always seem to see in a big data workflow, is simply because every organization has very similar needs with its data. So in this case, we utilize what's called a publish-subscriber model using the service bus, and we'll publish these messages, and we can store them in what's called blob storage. So there's a highly performant storage subsystem, Microsoft Azure, and it can scale up to 500 terabytes per storage account, and it's got a performance guarantee of around about 20,000 IOPS, which makes it fairly high performant. And of course you can scale this. You can shard across many accounts to give it specifically a very, very high IOPS capability that would be similar to something like an SSD, a solid state device. And in doing so, what we can do is we can accumulate and persist all of these messages. Then, as part of this workflow, we tend to want to drive schedules. So let's say we're accumulating thousands of these messages per day, or even millions. And then we run a scheduler. Then we would use HDInsight to process these messages at the end of the day, and they would give us some kind of intelligence. And through HDInsight, we can effectively create queries which will allow us to interrogate this data, even if we have terabytes of file information that are completely unstructured. So it's not source dependent in this case, but let's assume for a minute that I took different messages, and each one had different schemas. Some of the files that I created weren't even tied to a particular schema. I could build the schema on demand within HDInsight. And what I might want to do is I might want to schedule a job, and I might want to process this data. I might want to extract or filter, or I might want to transform it into a different form. And at the end of this, after 2 hours of batch processing, I'll push this into SQL Server. And there are a lot of ways that you can create SQL servers in Azure. There's a managed service called Windows Azure SQL Database, which again is a one-click deployment of SQL in the cloud, or you can manage your own highly resilient active passive clusters, any way that you're used to. And then at this stage, you can just use your standard mechanisms, even though you've been dealing with far more data than SQL Server can actually filter and store in its own right. You can just drive a report off the back of this. So the report can be using SQL Server reporting services. We've written reports using Tableau and Power BI. And then correspondingly, that same message bus that we've been using, the service bus, can then be used by another part of HDInsight, which presents an application called Storm, which will take all of these messages and will enable a much more real-time view on the data. So with Storm, you can store these messages in an intermediate cache, and you can effectively process them over sliding windows. So in the past, we've created Storm, and we've been able to show metrics across 5 minutes, 1 hour. We've been able to look at within a 5-second window of what happened yesterday and compare that 5-second window to that same 5 seconds the previous day. So you can end up with some really powerful context there. Next slide, please, Sarah. So the fundamental pattern that HDInsight uses, and HDInsight is an implementation of Apache Hadoop, which is a very popular big data framework. HDInsight is the platform as a service that Microsoft offer on Azure. And essentially, it all boils down to a pattern called MapReduce. And MapReduce was created by Google. It used to run some of the indexing on their search pages, along with their PageRank algorithm. And it's a way of taking a very large amount of data, mapping this data, and effectively aggregating it. So if I were reading values from a text file, I wouldn't care what each line of the file was. I can impose the schema in code. And there's a number of ways that you can do that. You can do that within a high-level language like Java or C#, or you can do that in a much more structured language, set-based language like SQL, through something called Apache Hive. And so what we do is we pipeline these MapReduces, and effectively we filter and transform our data with this pattern as if we were creating a data transformation pipeline. Next slide, please. I wanted to just mention that, that a lot of people in our experience have some great concerns about actually putting their data in the cloud. I think that that debate is for another day. It tends to be, security and compliance tends to be a very addressed problem at the moment. And people and organizations are obviously really trying to understand where the cloud fits into their data workflow, essentially because we would tend to feel that if our data is not residing on premises, then it's out of our control. as I say, that's probably a debate for another day, but suffice it to say that Windows Azure has a lot of protections in place to stop data theft, to stop things like network attacks, which where if anybody's interested, I can give you some pointers. Microsoft indeed has something called the Trust Center, which you can Google or Bing, whatever your search flavor is, and if you look at the Trust Center, it will tell you all about the levels of security and compliance in Azure, so you can make your own determinations. But one pattern that we've put in place in the past is to create very small clusters of Hadoop on premises, and then take data sets and completely anonymize them with every job that we do. Then push the data into the cloud, and then use much larger clusters on demand to actually process and transform that data to give us the analytics that we need. So it just means that on premises you can have a very small investment in a Hadoop cluster, and then you can use the capability of Azure and effectively create HDInsight clusters, which is Hadoop on Azure, on demand to process that data, and you can have far more resources for far less cost at that stage. Next slide, please. Okay, so that was a little bit about big data, and we'll hear quite a bit more in a few minutes when we talk about some of the case studies we've done. I want to discuss machine learning in the cloud, specifically because Microsoft have just released a new machine learning service called Azure ML. So if we could go to the next slide, please. So for those of you that don't don't really understand what machine learning is, this is in some of the talks that we give. This is like quite a fun example, which sort of brings this into a popular framework rather than an enterprise context. So so I think this must have been the February or the March issue of Wired, and one of there was a mathematician and computer scientist in New York that hacked a dating website called didn't physically hack it, but effectively wrote his own data processing algorithms to take a different view on the data, and try to mine this, try to find out things about all of the dates that this website was recommending and how it was doing it. So he effectively reverse engineered the algorithm that this website OkCupid had put in place, and I don't think he was having a very successful time on this. So he decided to apply his machine learning skills to this using Python. Python has some very extensive machine learning libraries, and he effectively took these data sets by what we call gaming the system, by inventing a bunch of fictitious users to actually generate a whole load of test data sets, and then use these to train a model based on what his perfect partner would be. And essentially he used a lot of machine learning techniques such as classification and clustering and neural networks, and you'll hear about adaptive boosting, and he put all of these things together to actually find his fiancée now. So it's quite a quirky story, but it shows you that that we have data, that we're generating all of this data in all walks of life, not just within the enterprise. And it's really how we can access that. The more data that we have, the more we can actually take to create very, very comprehensive models which will allow us to predict the next thing. If we could have the next slide, please. So, so actually Microsoft's machine learning is very much not nascent as people think. Even though this service is new, Microsoft have had a very, very good history of building machine learning tools, and indeed putting this into all of their products. There's a fantastic library called Inferred.net, which has been created by Microsoft Research. The reason it's not in wide use and only in academic use is because it only has an academic license, unfortunately. But it's been the backbone of a lot of really interesting systems like the Connect, which again Microsoft Research were involved in. So Azure ML is partially dependent on this library Infer.net, and essentially it's Microsoft running a machine learning service that allows you to drag and drop components in a very user-friendly manner to get together and prototype models very quickly. Indeed, we've been building a recommendation engine for a customer, and it took 20 minutes to prototype this without any rules or constraints. So, to turn this into a production system would take much longer. But it took 20 minutes to prototype this just with a tiny bit of script and some drag and drop in Azure ML. Then one of the great things about Azure ML is that it's really plugged into Azure, so that if your data sources and if your entry points are things like websites where you want to use web services to kick this off, you want to pull data from SQL, you have a very large number of files in storage, then you can use Azure ML out of the box to access these because it understands different parts of Azure already. It's also a great tool for data scientists. Data scientists frequently use a language called R, and one of the key support aspects of Azure ML is the ability to inject an R script into this workflow. If we can go to the next slide. So the workflow looks like this. This is actually the recommender that I was talking about, and I'll walk you through this. I put together a short demo which I've been showing in a few places, and effectively this reads some data from blob storage. It reads 1 million recommendations given by moviegoers, and it pulls out some columns in the form of the users, the movie IDs, and the ratings that each user gave, and then it splits these up. So you'll tend to find that machine learning uses this concept of training and testing to build its models. So we split this up, and we tend to say, let's take the first, this is much simplified, but let's take the first 80% of that data, and we'll use that to actually train our model and work out, how the algorithm that's going to predict the next 20%. So what we can do, therefore, is we can say, we'll take that 80%, we'll build the model, and then we'll score that. We'll determine whether or not that model that we've built is effective in predicting the 20% that we've held back, and we can give that a certain confidence level. The process is a little bit more complicated than that, and there's a lot of variations, but essentially that's it. It's being able to take part of a data set, to train a model from that part of a data set, and then to predict the next steps. And in this case, we output back to blob storage what our predictions are. So if we were trying to predict what the what the last 20% of users within that data set would actually look like, in terms of their preferences and whether or not they would have rated a movie like this or like this or like this with a 1, a 2, a 3, 4, we can actually test how efficient that model that we created is, and then we can write back the results to blob storage. If we go to the next slide, please. So, and then we can expose this to the world, we can expose this to a subset of users, literally through a one-click by creating a web service, and Azure will handle all the rest for us. Next slide, please. So these are just a few of the use cases that we can apply this to. The top one, predicting which employees need access to which resources, is a really popular one. At the moment, I think there are a lot of big companies like Amazon which have been trialing this out because you have a bunch of database systems and digital resources as well as physical resources, and to be able to look at the profile and background of people and what they're doing, and then apply machine learning to say this person needs access to this, this, and this, and predict that before they have to request things and make change requests and these kinds of things. There's a classic of self-driving cars which Google's investing quite heavily in. Predicting emergency wait room times, cross-selling products, which you'll hear about in an ASOS case study that I'll discuss. Determining which groups of users will spend what. Very, very common in the gaming case study that I'll talk about is to try to classify what's called the whale, that person that spends so much money on a particular game, and that's by actually there's some very, very tried and tested ways of using machine learning to do that kind of thing, and then to classify users' propensity to spend or to give or to do any kind of activity based on the journey that they take through a website. Next slide, please. Okay, and again. Okay, so the first case study I want to talk about is something that's ongoing at the moment for us. We've been working with ASOS for a couple of years now, and they've had some really good success as an online fashion retailer, and they ship to 134 countries. They don't have a store or outlet, which where a lot of companies have found success this way by minimizing their overheads. And you can see that they've got huge year-on-year growth, and they're a real success story for the UK. And they've chosen Azure to effectively as their technology stack, and they're really used to using a lot of Microsoft products and tools as well, like SQL Server. So the transition to something like Azure has been fairly successful. They've been applying a lot of the big data tools, and I think their key need, if we go on to the next slide, please, is to be able to understand and address all of the problems that they have internally, and these are problems that everybody has. So as you can see, this really depicts, how all of us actually abuse projects and data, and we end up with so many different data sources that we don't think that we'll be able to, accumulate any value out of them collectively, because some of them have got really complicated schemas which we don't understand, and applications just work off the back of them. And so I think the key thing is that a lot of this data will need to be made available in the right format, but we don't know what that is. So there's always this cost of transformation, and we talk about extract, transform, and load, which can be a very arduous and discontinuous process that's prone to failures. We generally have data that's available in multiple sources. So, we can have flat files from one system. We can have a relational database in another system. We can have something that that is defunct and doesn't have any support at all. We can have a web API which returns OData or JSON from one system. So it's really about taking all of these discrete data sources and pulling these together, aggregating them, and getting value, because we tend to find that to drive organizational analytics, everybody in the organization has got a part of the data story, but nobody's really got the whole picture. So if you could go to the next slide, please. So So ASOS turned to us and Microsoft Azure, and we began using HDInsight, which is Hadoop. You can see Hadoop, the yellow elephant there. It's become the symbol, effectively, of big data. And we pulled this data from various discrete systems to build them a recommendation engine. So there's obviously a lot of sales data which is accumulated over time, and there's customer data, there's data from various external systems like Web Trends and Adobe, and all of these have to be pulled together to be able to really understand not just existing users and to try to derive their preferences so that you can achieve some kind of cross-sale by presenting and recommending people with things that they'll actually want to buy. And that's really about understanding your customers. And to be able to do that, you've got different types of customers. You've got entrenched customers which have been using your service and buying things from you for years, but you've also got new customers that you don't know anything about. So you have to use different techniques and analyze data in different ways in order to get these new customers to get the right recommendations, so that they'll want to carry on using the site, they'll want to carry on buying things from you, and using HDInsight is a really good way to do this, as we've shown, and as ASOS are really heavily investing in. Okay, next slide, please. So another case study that I want to discuss is Tonic, which is a fantastic games company. They've been around for several years now. They've got a games as a service platform, GameFuel, and they average several million downloads per game. As you can imagine, there's a lot of traffic because gaming is all about telemetry. You generate events when you get to the next level. You generate events when you purchase something. You generate events when you pass messages to other users of the game. So there's a lot of data that's being generated, and to be able to leverage that in both real time and to be able to report back to the business is it's a really interesting problem. Okay, if we can move on to the next slide. So we'll look at the problems that we faced when we started this project. So the existing solution that they had was in Amazon Web Services, which used Hadoop. It used Redshift, which is a business intelligence tool. It used MySQL. Some of these are platform services, some of them are infrastructure services, some of them are relational databases, but there was a lot of discrete systems that all had to work together to be able to generate their analytics. Sometimes this failed, so they had to rerun processes because there were too many moving parts, and it's very difficult to create that resilience when you need to across such a large estate of different frameworks. So they already had the reporting infrastructure in. They were using Tableau and generating some business reports based on what was going on with the previous day. But the key to gaming is to be able to use A/B testing, which is effectively targeting a specific group of users and then trying something on them and then being able to test the results. So a key factor for the analytics solution was to be able to make some changes and then test the reactions of a certain group of people. And A/B testing is generally random. So when you have a bunch of registered users, you may divide them up into 100, a bucket of 1 to 100, and then test that bucket so that it's effectively a random sample. Or you might actually try to test to do more formal testing and testing certain aspects of users from a particular geography or locale, and being able to process and qualify the results from that testing on a 24-hour basis is really what they were trying to do. So if we go on to the next slide, we'll see how we achieve this. So we did this in a number of ways. We used a lot of different Azure services because all of these things were readily available out of the box. So we had Windows Azure websites that we used to collect all telemetry data using web protocols, HTTP, HTTPS. We used HDInsight for 3-4 hours a night to actually process the data that we parked in blob storage and stored there. Then we built a storm cluster, which is now available through HDInsight, so that effectively, if you remember the diagram that I showed previously, we ingested 5 million messages per day per game or thereabouts, and we were able to take these messages using the service bus, the Windows Azure subsystem component, and we were able to feed part of it into blob storage so that it was persisted, so that we had gigabytes of data per day that we could then process at night between 1 and 3 or 1 and 4 in the morning using a 64-node HDInsight cluster, and that would give the report for the business the following day. And we'd made it resilient. We'd allow it to retry if there were failures, and then at the end of every single batch process, we pushed the results into SQL Server so that Tableau could build the report for the business the following day. But Storm, which is the real-time processing engine, was also used to ingest these 5 million messages. Some of them it was not interested in, but some of them it was, in terms of being able to see in real time, which games and which users, what monetization levels were. So to be able to see these real-time charts and use the same ingestion processes for the batch piece was something that we did for them, which worked really well. So if we could go on to the next slide, and the next, yeah, okay. So the next one again is slightly different. We worked with JustGiving, who's since built a really good data science team. They're a large UK charity-based website, but they're a business, and they run fundraising campaigns on behalf of their customers, which are generally charities, but also a lot of individuals. And they handle millions in donations per year, and they support all kinds of fundraising, and they're a worldwide brand as well. Next slide. Okay, so when we arrived at JustGiving, we found that they had a very good classic Microsoft stack, which was great, but they didn't really understand things about their user patterns and behaviors, although their intent was to really build data science capability, which they've done very well. And they were missing a lot of opportunities with some really rich data. So we wanted to offer that insight to them, since they didn't have that much data science expertise, and they didn't really have any big data engineering capability at the time. And as they had that experience in the classic .NET stack, they didn't really understand frameworks like Hadoop, because they come from the open source world. So if we, next slide. Okay, so this was a very interesting project for us, because the JustGiving's intent is to really understand how the users are reacting in a social context to these campaigns, and that involves creating graphs of users. So I'm sure many of you have heard of graph databases. We used HDInsight as what's called a graph engine, and we enabled a project called Apache Giraffe, and in doing so, we were able to calculate with JustGiving this idea of the propensity to give, whether or not someone who gives to one campaign would be interested in giving to another campaign. And so very similar to this idea of recommending people things, but in terms of the techniques that we use, very different, because we needed to understand the degrees of separation between users. So if you imagine all of the campaigns as a very sort of holistic graph, to be able to understand how far away each of their customers, users, were from each other based on the certain types of campaigns that they give to. Okay, so if we could go to the next slide. We recently created our own big data platform because we could see that there were some new open source tools which were very complementary to Microsoft's offering, where we felt that there were certain workloads which fitted very, very well. So I'm just going to briefly talk about this for about 2 or 3 minutes, and then I'm happy to take some questions after that. Okay, so if we go to the next slide. So we created a system called Brisk, which any of you can sign up for and use currently for free. It's just moved into production over the last month, and it's a customized distribution of a new framework called Apache Spark. It's very, very fast because it works across a cluster's memory rather than disk, which is something that Hadoop does. But it suffers from a scalability challenge in that if you run out of memory, you tend to have much poorer performance when it begins to use disk. But if you can fit your data sets into memory, then you can query them very, very quickly. So things that may take tens of minutes in a Hadoop context, in an HDInsight context, will take mere seconds within Spark. But there's obviously a critical threshold to the amount of data that you can fit in memory, and memory costs far more than disk. So it's an economic trade-off with that time. But if you have that need to do analytics very, very quickly, then Spark and Brisk is a very, very good solution to this. And some of the things that we described in earlier slides, we've sort of made a fundamental part of Brisk so that you can schedule work and upload software to it and just run these big jobs against data sets in Azure storage. And unlike HDInsight, where you would have to use 2 discrete systems, Storm for a real-time capability and HDInsight Hadoop for a batch capability, Brisk and Apache Spark will support both. So we'll read messages off the service bus. We can stream live tweets, and we can do all of these things at once, and effectively treat them as micro data sets, and have these 5-second sliding windows, but at the same time be able to use the richness of this whole historical data set that may scale to terabytes that we can then read from disk. So next slide, please. So that's what Brisk looks like. We wanted to go through for a very friendly, very friendly sort of Azure-like interface. So it's very, in terms of the management aspect of it, it looks very similar to what the Microsoft Azure portal looks like, if any of you have seen that. Then what I just want to do is show you quickly the big difference. We looked at the slide on MapReduce, so if we go to the next slide, just so that you can understand the fundamental difference behind Brisk and HDInsight Hadoop. It's not actually easy. Hadoop is fantastic with working with very, very large data. In fact, each data node actually likes to split up data into 64 meg chunks. So HDInsight will perform absolutely fantastically across tens of terabytes of data. You can scale up to as much as you can, but it's not very good at doing joins we're used to in the relational world. So MapReduce is a very discrete process. It's a very discrete pattern, and we have to create several MapReduce pieces of software to build up that data pipeline. With Brisk, it's much more continuous. You can map different data sources together. Then you can run the reduce on this, so you can do aggregations in that reduce, you can do sums, and you can order the data. You can order the output of data, and then you can run things like linear regression on top of it, or you can run any machine learning process, all within the same piece of software. So it's very, very more continuous, I think, where Hadoop is a little bit more discontinuous. Next slide, please. So, yeah, very sorry. Just a little bit of code, but you can see here that what I showed you before is is embodied in these few lines of code, and it can be done interactively as well as putting into software. Now, in Hadoop, this would take 5 pieces, 5 separate programs to do the same thing. So in Spark, as I say, you're still inhibited by memory. So Brisk, for example, can create clusters of up to 3.2 terabytes of memory, but frequently there's data that's greater than that. If we go to the next slide. And there's also a SQL interface as well, and I wanted to just show you that that it's very easy to use SQL from JSON files, for example. If you've got NoSQL databases, or you're pulling JSON information from a web service, then you can load this into Brisk, and you can just run a SQL query across it like this, and it will infer the schema for you. So it's quite nice in that respect. And thank you. I'm finished now, and I'm happy to take any questions.
But if you do have any questions at any point, then do let us know, and thank you very much for joining us today.
Thank you.